Well, hello. I hope everyone is great today. Our task for today is going to be calculating the number of protons, electrons, and neutrons in different isotopes of elements. So do me a favor, take a moment, please write this I can statement down into your notes. I can calculate the number of protons, electrons, and neutrons in an isotope of an element. In order to do this, you're going to need two things. First of all, you're going to need information on the isotope, which is going to be right here looking like this, either an isotope written in shorthand notation or in hyphen notation. And the second thing you're going to need is a periodic table. Now there's no way you're going to be able to see this periodic table here, so will you please take a moment and open your textbook up to the back flap so you can use your periodic table to follow along. Also, at the end of this lecture, I would like you to take this worksheet that I gave you in class and fill out the 4 boxes. There are 3 boxes right here for lithium. See if you can determine each of lithium's isotopes, protons, electrons, and neutrons, and then the one down here for gold. Alright, so before we begin, I get started how to do each different particle, I want to review the term isotope. And isotopes are just different atoms of the same element. Alright, we talked about this in class. So they're the same element, they have to have the same number of protons in order to be isotopes of each other. Because remember, if we change the number of protons, yep, that's right, we change the element completely. Alright, and the thing that makes isotopes different is they're going to have different numbers of neutrons. That's the big key here. Alright, so let's go through and I'm going to show you how to find the protons, electrons, and neutrons for each of these 2 different isotopes. Right. First thing here, number of protons. That's the easy part right here. You're going to find the atomic number looking at your periodic table. And remember, atomic number is abbreviated capital Z. So take a moment, look at the periodic table, and find the atomic number for thorium and the atomic number for bromine. So we take a look at our periodic table that I just dropped, and we see that thorium's atomic number, our protons, are going to equal 90. Now find bromine's atomic number, and you're going to see that the protons for bromine equal 35. Next thing, determining the number of electrons is you take the number of protons and you subtract the ionic charge. Please take a moment and write this down. So one thing I want you to add about this is for neutral atoms, the number of protons will always equal the number of electrons. In order for an atom to be neutral, the positives must equal the negatives. So for our thorium isotope here, there is not an ionic charge, and there's not an ionic charge for our bromine isotope either. So in both cases, the electrons are going to be the same number as the protons. We'll practice one in a little bit where there's an ionic charge, so we can get practice calculating the electrons. All right, now for the next thing, the last thing, is calculating the number of neutrons. For number of neutrons, we have to have a mass number. And remember, mass number down here is a number of protons plus neutrons in the nucleus. So to calculate the number of neutrons is, we already know the atomic number, the number of protons. We're going to take the mass number A and subtract Z from it, and that will give us our number of neutrons. Here, let me show you. That number right here, thorium-230, that's our mass number. And the number 80 at the end of the hyphen notation here, that's also the mass number. So these are the numbers that we're going to subtract to find our number of neutrons. Thorium-230, we're going to subtract 230 minus 90. So there's 140 neutrons in our isotope thorium-230. And for our bromine-80, there will be 80 minus 35, 45 neutrons. And that's all there is to it. When you have neutral atoms, protons is the atomic number, electrons is the same as your protons, and then your neutrons is your mass number minus your atomic number. So let's do one example where there's an ionic charge, and I will see your homework tomorrow when you come in. So last thing we'll practice, here we have sulfur with a mass number of 32. And this time we're going to give it an ionic charge of -2. So first thing for protons, take a look at your periodic table. You'll see that sulfur has an atomic number of 16. Next, your electrons is your atomic number minus your ionic charge. So this is going to be electrons equals 16 minus -2. And you know what to do when you're subtracting a negative? Yes, you end up adding it. There are 18 electrons in sulfur with a -2 charge. And the last thing, the number of neutrons. Mass number A minus atomic number Z, 32. Minus 16, there are 16 neutrons in this isotope of sulfur. So come tomorrow, ready to practice. Thank you very much.